Configure vNetwork distributed switches and VSS policies. All right, so we're starting to move into the optional portions of this series, and I think from here on what we've got are some of the really interesting topics that are not necessarily core to the operations of your vCenter environment, but they are nice add-ons. We're going to talk about distributed switches, the storage appliance, fault tolerance, just a lot of these other things that the test requires you to know because it's VMware technology. They want you to be aware of it. But in many cases, these are going to be the kinds of additional sort of functionalities that you may probably want to implement at some point in time to solve certain business problems. In the case of vNetwork distributed switches and the policies that you assign to them, this technology was brought into play in order to solve a kind of a singular problem with the original standard switch architecture. Right, with standard switches, I've mentioned before, when you create a standard switch, you create that, it's very host-centric. Right? The switch configuration you create for ESX1 does not automatically propagate to ESX2, and so on and so forth. And so consequently, if you got 2 or 3 hosts, it's not a big deal. Right? You create your switches and you're done. But if you got 20 or 30 hosts, or multiple clusters, all of which have 20 or 30 hosts, you can see how these distributed switches start to get a little bit more, or these standard switches start to get a little bit more complex. You have to make sure that those settings are exactly correct across all the switches. And in fact, even vMotion, I believe, looks at the switch name between the different hosts to ensure where it can move virtual machines to. So it's got the right port groups as it moves them around. So just a couple of minor mistakes in your switch naming, and you can very quickly find yourself on a really bad day. So back in version 4, VMware actually created this whole notion of a distributed switch. Now, the difference between a distributed switch is that the virtual switch in this case is actually placed on the data center instead of on the individual host. And so being on the data center and having a logical connection to the individual hosts and the switches there allows the data center to manage the connections between all the different hosts. So it's like, I don't know, think of it like Windows group policy, right? You're creating a virtual switch policy, more or less, that deploys out to all of the hosts. Just like with the Windows group policy, you create a policy that deploys out to all of your servers. Now, you can almost argue that this whole distributed switch functionality, and we'll talk about that when we get down here to the click-by-click portion, this distributed switch functionality is kind of one of the directions in which VMware is moving as it relates to its product set. You know, a lot of the new functionality from out of VMware, the vShield product, the vCloud product, all that stuff really requires this sort of logical construct that's associated with the switches. And also some of the monitoring pieces, network statistics, network I/O control is another one. All of these sort of monitoring functionalities are ones that need to tag onto a vNetwork distributed switch, because from that location, in that single policy driven switch that then talks to all of the hosts, only there can you be guaranteed that you're going to be able to see whatever virtual machines you need to see in order to monitor their activities. And also so you can consolidate all of that network monitoring into a single location. So a vNetwork distributed switch is kind of an important add-on, completely optional. You don't actually have to add them into your environment, but a completely optional add-on for your environment, something you'll probably want to do, particularly as the size of your environment gets large. So here we are, vSphere client, same 3 hosts and 1, 2, 3, 4, 5 virtual machines running here. A VM1 is currently running right now. This is the standard switch that we created before, 2 of them. The first one here at the top is the virtual machine port group for the VM network, and then the VM kernel port down here at the bottom for our management network. And then we have 2 more ports over here for storage that we've got all nice and teamed together. So we've got iSCSI storage that's teamed for connection here. Now I have 3 physical adapters connecting to all 3 of these ESX hosts, and they're all being consumed right now. When we go to actually create a vSphere distributed switch, you're going to find that none of the adapters are available for attaching into it because they're already connected into all of the switches. And if you look, all of the switches are currently similarly configured. Now, when I go to create a vSphere distributed switch, you'll see that the creation process, the process you go through to actually initiate one and then attach hosts to it, is not done really from this button. You have to go first to Inventory, Networking in order to be able to do it. So if I go here to Inventory and then Networking, this opens up this My Data Center, VM Network, essentially all the networks that are here inside of the data center that we've created. You will create a new vSphere distributed switch at the level of the data center. You'll notice that there are 3 different versions. The 4.0, the original version, the 4.1.0 that added in, what is this, load-based teaming and network I/O control, and now the 5.0 version that adds in some new features like user-defined resource pools, NetFlow, and port mirroring. These are both really great new additions that we get out of version 5. So I'm going to create a version 5 switch here because it provides all of that new functionality. All the hosts, obviously, that you intend to add to this switch need to be at version 5 if they're to enjoy making use of a version 5 switch. Now, a distributed switch looks very much so like the standard switches do. We've got this gray box here, and on the left go the port groups, and on the right go, in this case, not the physical world items, but more like a logical connection to those physical world items. There will eventually be network cards that we stick in here, but for now, just think of it as the physical side. It's enough that, at least for this part of the explanation, that you can understand that these are kind of the physical side of the switch. Now you can create a number of uplink ports if you want. That's essentially the maximum number of physical adapters that you would have per host. Now I have 3 physical adapters per host and don't plan on having more than 3, so let's just put that down to 3 so that we have the number of uplink ports equal to the maximum number of adapters that we would intend to have on those hosts. I can give it a name here as well and click Next. And then in this screen is where I would actually identify the hosts and whatever available unconnected physical adapters that I would want to add into that vSphere distributed switch. There aren't any here. You'll notice that I don't actually have any available physical adapters in this list. So I'm going to actually add them later. I don't know. When I've created these things before, I've generally added them later because it just the follow-on wizard is a little bit more intuitive to use than is so here inside of this wizard. If you do want to click Add Now, though, you'll see that there are various settings here that are really defining how many ports are designated on this host. So 256 by default. Same thing if you hit the settings button up here. If you have any hosts that are incompatible for this version of the switch, you'll find them here, and it'll tell you why. Perhaps it's a host that's not at version 5, for example. So I'm going to add those hosts later and click Next and Finish. And so what you'll see is this new DV switch that gets created. Here it is right here. I have a DV port group, no VLAN that's currently assigned to it, and I have the DV switch over here on the other side. If I zoom out just a little bit, you can see pretty much about the same thing. See if I can minimize that. So here is the DV uplinks here on one side. Here's the port group on the other side. Just like we were talking about before, this is the same kind of left-right scenario that we were discussing before. So what we have to do at this point is effectively begin defining in the physical side of this switch. So what do we want to add in over here on this side in order to support the things on the other side? Now you have to be kind of careful here, especially if you already have an existing production environment up and running. As I mentioned, in our world today, in our little environment here today, we already have all of our network connections. They're already functioning, right? They're already virtual machines are making use of the existing standard switches. And so moving them into this DV switch situation is actually going to cause a bit of an outage for those virtual machines because, unfortunately, I only have a single connection for that standard switch's virtual machine port group. So if you have an existing environment, there are some migration sort of thinking, some migration activities you'll have to do to make sure you don't lose access while you do this. In the meantime, however, what we do want to do is actually get some of these different things up and running. Now, the first thing we can do is click over here to take a look at the DV uplinks. So these are again, the right-hand side of the equation and what different uplinks that we've configured in here. I have a name, I have a description here. You may intend to change the name here if you want to make it a little more useful for your uses. And I can also set in here some policy information as well. Same sort of stuff, promiscuous mode, MAC address changes, forged transmits, ingress and egress traffic shaping now, the VLAN that's set for this. Let me scroll that back up here. Here's the VLAN in terms of what VLAN type we're actually using. The teaming and failover settings. There's the failover order. And the resource allocation information, monitoring, and miscellaneous information. So these are all then defined further if I click down here to take a look at the specific settings here. And I'm not going to re-go over all this stuff with you again, because all of this is essentially the same sorts of settings that you've seen before when we were taking a look at the standard switches. Now, what's different here, however, is this resource allocation, monitoring, and miscellaneous stuff. Now, what's different in what you see here is this resource allocation, monitoring, miscellaneous, and the advanced stuff in here. These are different because these are where you could actually identify a network resource pool, okay, and you could use networking configurations, right? So how many network resources are you using as a measurement for your allocation of resources, okay? Network I/O control is a mechanism that allows you to limit the virtual machine's use of its network resources just in the same ways you would CPU or memory. And this is a good thing. If you have a virtual machine that's using far too many resources, well, it's nice to be able to lock down that VM so it's not over-consuming its fair share of resources in the whole environment. The monitoring piece here allows you to disable or enable the NetFlow settings. If you have a network monitoring solution that supports NetFlow, NetFlow presents a way for you to determine high-level statistics about what kinds of data is moving around your network across what protocols and from where to where. So this high-level information, not at the packet level, but at the flow level, gives you a really good idea of who's talking to whom and why. Down here at the bottom too, do I want to block ports? That would shut down the ports in the port group. Obviously that would disrupt the normal network operations of the hosts of the VMs using those ports, but the opportunity is here. Perhaps you've got some sort of situation where you need to close off ports on this switch. You could do so. So all of these are settings here on the right-hand side of the equation. You'll notice here on the left-hand side of the equation are the same sorts of settings. Now, these settings are going to be available to you, right? The other ones were grayed out because we had not selected down here at the bottom the override of port policies and what those override settings were. Now, again, no different here than what you're used to seeing on the other side, but this presents the ability for you to configure what the behavior of that switch is going to be. Now, at this point, what I want to do is I want to take back here, so let's go back here to hosting clusters for just a second, and I want to go back to networking in this vCP standard switch. To keep things relatively simple, what I want to do is across these three servers, migrate vmNIC 0 from the standard switch over to the distributed switch. Okay, you could at some point in the future go and do your storage switches as well, but for the sake of simplicity, what we want to do is actually go about the process of migrating this vmNIC 0 and all of its port groups and management network connections from this standard switch ultimately over to this distributed switch that we'll see here just in a second. I'm going to do that for all three of these hosts. Now when I do that, these virtual machines are going to experience a bit of an outage. Again, I only have that single connection right here. So in a production environment, I would probably have more than one connection up to my production network. So I could do this perhaps one at a time, or move virtual machines around and then do it one host at a time. Or there are an array of different solutions for making sure that you don't end up with a service failure in order to be able to do this. But again, for the sake of simplicity, let's actually worry about just getting those things moved over very quickly. So let's go back here to networking. What I want to do is I want to add hosts. And you'll see that I have the different hosts that are available to be added. Okay, here's ESX1, 2, and 3. And here are the physical adapters that are currently attached to those hosts. Now, if I view details here, this gives me a little bit more information about that adapter and just what it is, what it supports, what it can do. Again, I can view incompatible hosts if I want to, or I can just adjust the settings here just like before. What I'm looking for here is to migrate the primary adapter vmNIC0 for these three hosts over to this new uplink port group, DV switch to DV uplinks 1, 2, 3. All right. When I do so, you'll notice that I have in this next screen, and this next screen is a little bit complex. This next screen provides a location for me to assign the adapters to a destination port group to migrate them. Now what this is saying here is that the port VMK0, which was assigned to the management network here, needs to be assigned to some sort of destination port group here on the right-hand side. VMK1 and 2, these virtual adapters here, are being used for storage, and we're not really ready to migrate those just yet. So what we want to do here is switch this so that these will actually move over to DV port group, and I can do so over here by flipping the drop-down box over here, or I can click on one and choose Assign Port Group, just like this. I got a little warning dialog box here, or warning icon here, to remind me that the virtual NICs marked with this warning sign may lose network connectivity unless they're moved over. So this kind of gives you a warning to let you know what might happen whenever you make this migration occur. When I hit the next button here, the next thing we have to do is identify if we want to migrate the virtual machine networking too. So this first item here was for the management networking. The second thing we want to do is, all right, so once we move over the adapters to this new port group, do we want to actually migrate over the VMs as well? Again, in an environment where you're already up and operational, this step is probably one of the last steps that you're going to accomplish. You may do so here, or you may actually do so within the individual virtual machines options dialog box. So if you go to View and Edit Settings. Now here what we can do is take a look at all the different virtual machines and their different NICs that are associated. And we could say, you know what, it's time to migrate over VM6. We want to migrate over this one. Let's take it over to the DV port group, and same thing with its network adapter. And in fact, you know what? Let's just go ahead and migrate all of these virtual machines because they're effectively all needing to attach to that virtual machine port group. So let me choose DV port group here, and you'll see that now all of those that are on the VM network are going to move over to the DV port group as we complete this migration. Choose the next button here, and there is a picture of what we're essentially going to be creating here on this distributed switch. Again, on the right-hand side are going to be our uplinks. Here's vmNIC0, ESX1, 2, and 3, and then some new ports down here. And on the left-hand side, we have the VM kernel ports we're moving over. Those same IP addresses are going to be located there, and then all the virtual machines that we need as well, along with all of their networking. If I click the Finish button, we go through completing the task here. This takes just a minute or so for it to make this change. And then now these configurations are going to be brought into management underneath this distributed virtual switch. Once we get through here and we allow this to refresh, then we'll get a chance to see what this new changes are going to look like to us. Here are our VM kernel ports. Here are our virtual machines. Here is our uplinks over here on the right-hand side. So you can kind of see a nice, real graphical explanation of what we're trying to do here between taking those physical NICs, or as I mentioned before, these logical connections to those NICs on the right-hand side, and then connecting them to the logical ports over on the left-hand side. It's very, very similar to what you're used to seeing back with your standard switches. And in fact, you'll notice if I actually switch back over to our old view over with the standard switch here, that a couple things have changed. First of all, vSwitch 0 currently has no adapters over here on the right-hand side, and the virtual machine port group is effectively empty at this point. You could more or less remove this standard switch if you wanted to at this point, because you're really no longer using it. None of the VMs are using it, nor are any of the physical adapters. Over here now under the vSphere distributed switch shows me the elements for this host that are being managed at the distributed switch level. Here I have my VM kernel ports over here on the left-hand side. That's the one assigned to ESX1, and then the virtual machines that are also currently on that host ESX1. I can click to manage the virtual adapters or to manage the physical adapters up here, again, just related to how all of this works for this specific host. Now, you're probably best served by doing most of your network configuration here inside of the networking node or the networking view, because it's here where you can go about making those configurations from an entire environment, entire data center perspective instead of a host perspective. If I take a look here to manage hosts, I can go and adjust some host configurations here and physical adapters and network connectivity if I want to. I can also go through and manage the port groups as well. You'll see here are the same 7 items that we saw earlier, but in this case what we would do is manage them on a policy basis as opposed to an individual setting basis. So for example, if I wanted to change all of the VLAN settings for all of the items in here, I could do so by choosing VLAN and then the port group I wanted to, and then what is now the VLAN that I want to configure for those. No more is there a concern about setting a VLAN in one spot correctly and then missing it in another spot, because I'm creating all of these configurations from a policy basis and not just a specific host basis. Lastly, up here is Edit Settings. Here in the Edit Settings view, I can take a look at just those same sorts of settings that we're used to seeing with the regular switches. The name, the number of uplink ports. Over here in Advanced are the maximum MTU size. I have some additional information here about the discovery protocol and what would be used there. Even some administrator contact information if I've got a lot of people that may be needing to understand who's working on this host. Network adapter information here. Here's the connection between network adapters and hosts. And then lastly, my private VLAN, NetFlow, and port mirroring information are all made available up here. Now, a distributed switch, one of the things it does allow you to do is to create some internal private VLANs which have special uses. For example, if you want to create a VLAN that only has the ability to connect with other private VLANs, those are a possibility once you create a distributed switch. Again, these private VLANs are useful in certain circumstances whenever you want that VLAN to exist inside your data center. If I have NetFlow, I might want to set up the collector settings and any advanced settings, and then also the VDS IP address for that collector. These essentially send the statistics about who's talking to whom and at what level through to that NetFlow collector. And if I need to do port monitoring, essentially watch what's going on a port, if I want to do packet level inspection, I can do so here by adding in what sort of port monitoring solution, and then where does that solution exist and what is it looking for here in this location. So these are the additional configurations that you'll actually use whenever you make that jump from standard switches to distributed switches. And I think you'll find that the whole process of working with these distributed switches makes the whole activity of managing virtual machines and managing their network just that much easier. So working with distributed switches, a great solution for vCenter and a great solution for helping you improve that whole process of making sure you've got the right configuration across all the hosts in your cluster. So what have we talked about this nugget? We talked about distributed switches and how you can now, with a distributed switch, define the settings for all of those ports and port groups via a policy basis. We talked about why distributed switches are really kind of the way to go, and where all of the new technologies are going to lead people into the future as we add on more VMware technologies. And then we also spent some time working with those distributed switches and the port and the uplink groups that you would create associated to them. I hope this has been informative for you, and I'd like to thank you for viewing.